Title of the experiment: Numerical aperture of an optical fiber. Aim: to determine the numerical aperture and acceptance angle of the given optical fiber. Apparatus required for this experiment: LED light source, step index optical fibers of length 1 or 2 meters, numerical aperture jig. Theory: optical fiber is a very thin, flexible fiber made by the transparent medium through which light signals can be sent with very little loss of strength. Principle: optical fiber works based on total internal reflection principle. That means the light launched inside the core through its one end propagates to the other end due to the total internal reflection at the core cladding interface. Numerical aperture represents the light collecting capacity of an optical fiber. It is defined as the product of refractive index of surrounding medium and the sign of maximum acceptance angle. Na is equal to n0 sin theta maximum. If surrounding medium is air medium, then n0 is equal to 1. Numerical aperture equation becomes Na is equal to sin theta maximum. Here theta maximum is acceptance angle. The acceptance angle of an optical fiber is maximum angle with the fiber axis at which the light ray can enter into the fiber in order to be propagated through it by total internal reflection. Experimental arrangement. When LED light is passed through the optical fiber by total internal reflection and reached to the second end, this light is focused on the screen as circular spot. Let us consider the spot diameter as W and the distance between fiber end and screen as L. Now let us see the derivation of formula for numerical aperture. From this triangle OAB, sin theta is equal to OB by AB. According to Pythagoras theorem, AB is under root of OA square plus OB square. From this diagram, OA is L, OB is W by 2. By substituting the values in this equation and after simplification, we get Na is equal to sin theta maximum is equal to W by under root of 4L square plus W square. By taking the sine inverse of Na, we will get the acceptance angle. We use these two equations to find out the Na and acceptance angle of given optical fiber. Now, let us see the demonstration of this experiment. Let us see the apparatus required for this experiment. Fiber optic transmission kit, optical fiber, numerical aperture jig. Fiber optic transmission kit consists LED. When we switch on this kit, LED light is coming out from this port. This LED light we are using as a light source for this experiment. One end of the optical fiber is connected to the kit at this position and the second end is connected to the numerical aperture jig with the help of screws on both sides. Numerical aperture jig consists of two parts. First part is scale, it's a normal centimeter scale only. Second part is screen. A circular pattern is already there on the screen. The diameter of each circle is already given on the screen. First circle diameter is 10 mm, second circle is 20 mm, third circle is 30 mm, so on. When we switch on this fiber optic transmission kit, the LED light is passed to the optical fiber by total internal reflection and reached to the second end. After emerging out from the cable, the light is focused on the screen, which is exactly placed in front of the fiber end. So this is the experimental arrangement. Now let us start taking readings. Start experiment. Initially fiber end and screen both are in contact. Slowly separate this screen. Move the screen away from the fiber end until the light spot cover the first circle. Now you can see the light spot is completely covered the first circle. Stop the screen here and take reading on the bottom scale. So the separation between fiber end and screen, that is capital L. So value is 0.7 centimeters. The width of the first circle is 10 mm. So now let us take second reading. For that purpose, slowly separate the screen, move the screen more away from the fiber end. We know that as distance is increasing from the fiber end, the light spot diameter is increasing. So that's why. So see here, now the light spot is completely covered the second circle. At this position, stop the screen and take reading on the scale. Okay, so the scale distance is distance from the fiber end is 1.6 centimeters. 1.6 centimeters for the second circle. Length is 1.6 centimeter. Second circle diameter is 20 mm. In this way, continue the experiment. Take the readings for third and fourth circles also. After performing the experiment, we have to record the values in this table. Serial number is the first column of the table. Second column is L, the distance between fiber end and screen. W is light spot diameter. Both L and W values we have to write in millimeter. By substituting L and W values in this formula, we can calculate the numerical aperture. By taking the sine inverse of this NA, we can calculate the acceptance angle of the fiber. In this way, for different L and W combinations, we have to calculate the numerical aperture and acceptance angle. Finally, the average of all these numerical aperture we have to calculate, and average value of all the acceptance angle we have to calculate. This average numerical aperture and average acceptance angle values we have to write in the result.